Hi dear students, we are going to start a new video and new chapter. We are going to learn about the matrices. Here, general knowledge about the matrix, it's written here using the matrices to organize the data. If we have a group of data, if we need to organize them, generally we are using the matrices. And here we are going to start with the root matrices. The diagram shows the network of roads connecting the 4 towns A, B, C, D. Here, the information about the number of routes between each town without passing through any other town can be stored in a matrix like this. Here, if you see here from A to A, this from A to A it's going to be. So from the city A, if we say these are the cities, from the city A to itself there is no route, but for B there is. I'm going to explain that one later. So from A to B there is, A to C there is. So here there is one road and one road to C. From A to D there is no route, that's why it's written 0 here. Okay, then here we are going to start with B. From the B to A there is, from the B there are 2 ways to itself. One of them to this direction, the other one to this direction it's going to be. That's why it is written here 2. Okay, the next one is from B to C. As you see, from B to C 1, 2, and there are 3 routes. So here B to C we are going to have 3 routes. Okay, we are going to write 3. And from B to D direct route we don't have. That's why again it's going to written it's going to written 0. Now from C to A we have 1. C to B, these are all back. It's going to return 1, 2, 3. So there are 3 routes. From C to C itself, no. From C to D there is only one road, and that's mentioned here. So we are going to come to row D or C to D. From C to D to C to A we don't have any road. From D to B we don't have. Also you can follow, these are from the figure. From D to C 1 road we have, as you see here. Then D to D with itself there is no road. So you need to be careful about here 2 things. That if there are 3 different paths from B to C, you should mention with 3. And if there is a road from B to B, as you see circle, you should think 2 ways to this side, from right to left, from left to right. You can think about it. Okay, the next one, we are going to create our matrix by ourselves. Here we have to mention, only before starting I want to mention here the arrow here. So from A to B, as you see, from A to B there are 2 routes it can be, but from B to A we cannot return this road back, because there is a direction. This is one-way route and there is no return back on this route. That's why we are going to be careful about that one. Now I am writing the cities A, B, C, D, and E, and to A, B, C, D, and E it's going to be. From A to A, there is no circle, it's around itself, it's going to be 1. Pardon, so there's no circle here, there's no route A to A, that's why we are going to make it 0. A to B, 1, 2, it's going to be, there are 2 ways, A to B. And A to C, there is only one way, 1. A to D, there is only one way. A to E, there is only one way again. So from A, 2 roads to B, 1 road to C, and 1 road to D, 1 road to E it's going to be, and all we mentioned here. From B to A we have normally 1 route. It seems that here there are 2 lines, but as I said before, this road is one-way road. That's why this is going to be B to A only one. Then B to C, B to B. There's no circle here from B to B again. That's why this is going to be 0. From B to D, there is no direct road. B to C, I'm sorry, there is 1. B to C 1. B to D, there is no. B to E, there is no road. Okay, so we are going to continue with C. C to A 1 road. C to B 1 road. C to C, from the previous one we remember, you can go to left or you can go to right, and there are 2 ways to C. If you return to clockwise, 1. If you return to anti-clockwise, 2. Okay, there are 2 routes. And from C to D, there's no route. From C to A, there's no route. Okay, let's continue with D. D to A, only 1. D to B, no. D to C, no. D to E, 1. And D to D itself, no. D to E, 1. It's going to be, but from E to D, there is no road. Let me remind you about that one. E to A, yes, 1. E to B, no. E to C, no. E to D, no. This is one-way road. And E to E itself, no. So this is the network matrix it's going to be. Okay, now let's continue with the adding and subtracting matrices. If you remember, I said at the beginning, we are using the collecting the terms together, like here, as you see, the medals of the China in 2008 and medals of China 2012, and 2008 USA has won and 2012 won in Olympics. Probably these are Olympics. And 51 gold, 21 silver, and 28 bronze China won in 2008, and in 2012 80, 38, 27 and 23 is going to be. So with respect to this one, these tables, we can calculate the total from each data, each entry. Let's say 51 and 38 can be added to each other, 89 it will be. So this group data can be shown as matrix as shown below. 81, 21, 28, the medals of China, 36, 38, 36, the medals of United States, and China's in 2012 medals and USA medals. Then add them up, you can get the total. And in that total, you are going to see that this entry and this entry you are going to add, and this entry and this entry together you are going to add. So each entry with respect to number of rows and columns, intersection of number of columns, you are adding them together. So you cannot add 51 and 27. You can add 51 to 38. Okay, so the size of order of matrix also it's called, here this part is also important. The size of a matrix, it is called order of a matrix. So we are understanding here from the order, we are understanding like row number times column number. I couldn't write. Times column number. Column number. And here, if I write for the here resultant matrix, which is 89, 48, and 51, the 82, 67, and 65. This is 2 by 3 matrix because there are 2 rows here. 1, 2, first row, and second row, I can say. And here, this one, it's going to be first column. So this is 2 by first column, second column, and third column. 2 by 3 matrix it's going to be. And while we are reading, we are calling 2 by 3 matrix, this one. And you can add only, this one is important information here, you can add only 2 matrices if they have same size. Okay, 2 by 2 matrix can be added to 2 by 2 matrix. If it is 3 by 3, you cannot add these 2 matrix. And one example I'm going to solve, then I'm going to finish. Here I want to solve the A plus B. Since they are both 2 by 3 matrix, 2 by 3 and 2 by 3, I can add them because the sizes are same, order is same also. A plus B means that here 6 plus 4, the first entry and the first entry it's going to be. Then I can change the colors here. Then 1 and -1, which is -1 plus 1 it's going to be. Then yellow, or which is suitable to this one here, 3 and 3, I'm going to add 3 plus, and here it's going to come 3 plus 3 it's going to be. Then I'm going to add the next one, like here 0 and 2, 0 plus 2 it's going to be, and another color, maybe black. Here it's going to be 7 plus 4, 7 plus 4 it's going to be, and the last one maybe we are going to choose different color, like this one here, like brown. It is 2 plus -1 it's going to be. So this is the end of the solution. Actually we didn't finish, but I can finish like this. Here it is, or let me write to this side, it's going to be much better. Here this is going to be equal to 10, 0, 6, 2, 11, and here 1. Okay, 2 plus -1, it's going to be equal to 1. Then A minus B, I can write here, A minus B. This time I'm not going to write with different colors, all of them in same color I'm going to write, which is equal to here 6 minus 4, 6 minus 4, it's going to be -1 minus 1, -1, 3 minus 3, it's going to be 3 minus 3, 0 minus 2, 0 minus 2, 7 minus 4, 7 minus 4, and 2 minus 1. 2 minus -1, it's going to be. So it's going to be equal to 6 minus 4, it's going to be equal to 6 minus 4, it's going to be equal to 2 minus 1 minus 1, it's equal to -2. 3 minus 3 is 0, 0 minus 2, it's equal to -2, 7 minus 4, it's 3, and 2 minus -1, it is 2 plus 1, which is equal to 3 also, it's going to be. This is A minus B matrix, it's going to be.